Being the clever mathematicians that you are, I'm sure you noticed some special cases or patterns as we did factoring in the past. So our first one is the difference of squares, DOPS-PAT, difference of squares pattern, or difference of perfect squares. So if you have two perfect squares, a squared and b squared, they're both perfect squares, this is the format that will remind you how to factor. So let's look at our first example. 16x squared is a perfect square, and so is 25. Difference is because they're subtraction. So difference of perfect squares pattern. The square root of 16x squared is that. It's 4x. The square root of 25 is 5. So it's the square root of the first, the square root of the second, and then one negative, one positive. We call that DOPS-PAT, for difference of perfect squares pattern. So, example 2. X squared minus 1. Well, square root of x squared is x. 1 is also a perfect square that many forget about. So, different square root of the first, square root of the second, plus and minus. Now the next one, notice that it's an addition, not a difference. It's not a subtraction. So even though they're both perfect squares, you cannot factor them. This one's neat. So we have x to the fourth. X to the fourth is a perfect square because x squared times x squared is x to the fourth. So when we do that, notice that here we have, again, a difference of perfect squares. So we're going to factor that one again. The right one remains the same. The left one factors again. Yeah, let's go ahead and do the next one. So then the other one is perfect square, factoring perfect square trinomials. Perfect square trinomial. So what does that mean? Well, if I take a binomial and square it, multiply it by itself, that gives us this pattern, right? So there's the work that gets us to that pattern. So if I have a perfect square, and then double the root of each of those, that you should recognize as a perfect square trinomial. So anything like that will factor. If it multiplies out to give us this, then it factors to give us this. So here's our first example. Notice that the beginning and end, x squared and 64, are both perfect squares. And then also notice that if I take the square root of each, that's 8 and that's x. 2 times 8x is 16x. Oh, that shouldn't be a square, sorry. That's how that should look. Now that will factor to 8x plus 8, which is x plus 8 squared. All right, so look at the second one. We have two perfect squares for A and for C. The square root of each is this and this. When I multiply them all together, it gives me 30x. But notice that it's negative. So that's actually must have been a negative 5, because negative 5 times negative 5 would give us a positive 25. So then that is how we get the negative middle term. That would be the factored form, and then we write it condensed as that.